Now my task here, if I can manage it, is to make an equilateral triangle, and these are the shapes I can tile with, any number I like of the purple and the blue, and the purple is twice the size for area of the area of the blue. Both equilateral triangles, and I'm trying to make an equilateral triangle. The orange paper I've cut here, so that's 60 degrees. This is a start corner for me for the equilateral triangle. Perhaps it starts with a purple here, and somewhere further along perhaps there's the blue, and maybe I can fill that with other purple and blue triangles. Maybe this corner was blue, and this is somewhere, and maybe it's purple that fills the interior. But my task is use the blue and the purple and end up with an equilateral triangle of some size. Now I have other shapes, same task, but other shapes to use for the tiling. I have isosceles triangle. These two sides here are equal. There's another one I'll need in a minute. And the other shape I'm using is an equilateral triangle, and the relationship between these triangles is that the side of the equilateral triangle matches the length where there's a pair that are equal for the isosceles triangle. So it might be this time that I start by making 60 degrees, putting two isosceles triangles in like that. Maybe somewhere else the other corner end of the baseline for my equilateral triangle, and the space inside to be filled somehow with other isosceles and equilateral triangles. So my task, as before, is to make an equilateral triangle of some size using the yellow and the red, the isosceles triangle and the equilateral triangle. In mathematics, one reason we pose problems to ourselves, to each other, is to focus our energy, but what we're really trying to explore is the structure that's there. So in this task, trying to produce an equilateral triangle, what we're really going to discover is the relationship between the shapes that we're using, perhaps the yellow and the red triangles, or maybe the earlier ones where we had the two different sizes of equilateral triangle.